Good afternoon. If we can take our seats, we're ready to begin. Continuing our seminar with Richard Walker, and we're going to be talking more this afternoon about creation, myth, or miracle. Where does the evidence lead? And I'm going to ask Mark Dexter to come up here and lead us in a prayer.
Let's pray. Heavenly Father, as we come to you, Lord, we just want to thank you for the meal, and for our break and our opportunity to talk about and think about these things that have been presented to us. Help our minds and our hearts to be open to learn the message that you have for us. Pray that you help us to look at your word and look at science with a new boldness and a confidence that there is no battle between science and religion, but that you have used this to build our faith and to teach us more about your creation and about you. In Jesus' name we ask it. Amen.
Amen. Thank you. How's this for a sound check? Is that good? Good. Okay, great. I really appreciate one comment in the prayer. It made me remember a correct statement. The Bible does not say that that Christians are transformed by the removal of our minds. It says we're transformed by the renewal of our minds. There isn't a locker out there where you remove your brain and leave it when you enter the church. There's no need to think that way. Okay. I'm going to jump into some of the evidence that does relate to the age of things. Oops. I probably did that. This is one of the more recently named dinosaur fossils. I just love the name of it. Plus, if you look at that skull, whoops, there we go. I got real loud all of a sudden. What did I do? If you look at that skull, that looks like the caricature of a medieval dragon, doesn't it? In fact, look at the name, Dracorex hogwartsia. That is its scientific name, the Dragon King of Hogwarts. There's a top view. There's the teeth. I just like that skull. That's just an interesting dinosaur skull. Now, what I want to look into is some recent information from dinosaur bones. And there's a lot of new information that's been added in just the past few years. But in reality, it goes all the way back to 1993. It's been 20 years since this first started getting announced. What happened was, that's Mary Schweitzer up there. She's now a professor, I think, in North Carolina. She was a grad student doing archaeological research, dinosaur fossil research, with Dinosaur Jack Horner, who is one of the most well-known dinosaur paleontologists around. He was the technical consultant on Jurassic Park, and he's often on Discovery Channel and various shows. She was working with Dinosaur Jack Horner up at Hells Creek, I think is in Montana. And they had a problem. One of the T-Rex bones, leg bones, was so big they couldn't helicopter it out. They encase it in concrete and stuff to protect it. And it was simply too large to take out in one piece, so they were forced to break it in half. And then they would reassemble it at the lab. Well, what happened was they looked closely at some of the contents of the inside of this T-Rex bone, this leg bone, great big bone, and started examining what was in there and found some things that, as Mary Schweitzer said, this is from back in 1993, this particular article. And here's what she found and was looking at under the microscope. It was exactly like looking at a slice of modern bone, but of course, I couldn't believe it. I said to the lab technician, these bones are, after all, 65 million years old. How could blood cells survive that long? What she saw under the microscope from the inside of this T-Rex bone made no sense at all scientifically. And but there was documentation of her saying these things 20 years ago. And I remember seeing it back then. And creationists are saying, we're not surprised. That bone is not 65 million years old. There's some physical. Interestingly, all through the 90s, the main rebuttal to that was, you're lying. Nobody ever found that, and nobody ever said that. They just flat out accused creationists of making it up despite the fact it was published. And then they started saying, okay, well, it's published, but Mary Schweitzer, they don't know what they're doing. It's biofilm. It's just contamination. So their science got accused of being faulty for years. Well, I'll show you some more slides, but let me tell you, it's been replicated. It's been done over and over again by Mary Schweitzer and other researchers. This type of soft tissue find has been discovered in numerous, supposedly, bones from 65 million years ago. It's become beyond question that this is actually there. But let me show you some of the important statements and why this was being pointed out by creationists. So she says she couldn't believe it. How could you possibly have blood cells that long? Here's some of the pictures from the microscope. And I'm going to show you a short video also with an interview with Mary Schweitzer. When I show you the video, it's only about 4 minutes or so long. Listen carefully to what she says toward the end of it about science. What does science say about the ability for these structures to still exist? Listen closely to what she says. But here's some of what she found. What they did was they dissolved away the calcite, the mineralization that was around the soft tissues. They dissolved that away, and this is what was left. So this is original material. At first they weren't sure. They thought this can't really be stuff from this dinosaur. That has now been moved, that question is solved. It is original material. No question about it now. But here's what you said. The tissue fragments on the left, they're still flexible and resilient. You can stretch them. They snap back. Regions of bone show fibrous character not normally seen in fossil bone. Well, translate that. Can't possibly exist in fossil bone. And we'll tell you why. So this was documented now in 2005. And the interview that I'll show you in a minute is it's around 2006 or 7, I believe. Look at the title of the article, Soft Tissue Vessels and Cellular Preservation in Tyrannosaurus rex. Okay? So the issue is these things are still there. That's what was being discovered. Here's some more. Dissolved T-Rex bone yielded flexible branching vessels, some of which contain cell-like structures. Okay? Mary Schweitzer's a careful scientist. She was careful to not overstate what she was finding. I don't think it's in the interview I'm going to show you. I think it's a different one, where she said, I didn't believe it till I'd replicated it 17 times. Okay? That's a good scientist for you. Okay? She's been very careful. She was attacked like crazy as being just shoddy. And as I said, reproduced it numerous times, and it just simply is beyond question now. And we'll get to how science, secular science, is attempting to deal with this information in a minute. But this is what's stuff inside T-Rex bones. Now, why is it a problem? Look what Schweitzer said. If you take a blood sample and you stick it on a shelf, you have nothing recognizable in about a week. So why would there be anything left in dinosaurs? The problem is chemistry. The problem is these structures dissolve quickly. They just simply don't last. And so that's the real question, is why would this be left? Now, she's trying to get articles published about these discoveries, right? The mechanism is you submit your article to an editor at a journal. They give it to reviewers. The reviewers look at it, theoretically, and maybe give you feedback. Yes or no, is it valid? Should it get published, etc. Look what she said. I had one reviewer tell me he didn't care what the data said. Remember Scott Todd? Doesn't matter what the data leads. If it's not naturalistic, it's not science. Here's a reviewer in a scientific journal saying, I don't care what data you show me. He knew that what I was finding wasn't possible. Now, why isn't it possible? Because the bone is in fact, this case it was 68 million years old, supposedly. That's why it isn't possible. So the age is unquestioned. And they're saying, that can't be there. I wrote back and said, well, what data would convince you? And he said, none. Now, there's a good open-minded scientific reviewer for you. I don't care what data you show me, this cannot be in a 68-million-year-old bone. Problem is, it is. And so what do we do with that? This is also kind of interesting. This is sort of a passing comment that she made. She recounted how they're digging up these T-Rex bones in Hell Creek, Montana, and it smells cadaverous. Now think about that for a minute. You're digging up bones that are supposed to be 68 million years old, and it smells cadaverous. What's going on when you smell something? You've got molecules entering your nose, and you're sensing them, and you smell something. Those molecules still exist. Okay? Does something that's been dead for, 5,000 years, does it still smell cadaverous? Not a chance. These things smell cadaverous. And she mentioned it to Jack Horner, and he goes, oh yeah, all Hell Creek bones smell. I looked at that and I thought, talk about ignoring evidence that's right in your face. So for all the time they've been digging these up, there's physical evidence in the cadaverous smell that these things they're not in the state they ought to be in chemically and biologically for their age. Something's wrong. Never even looked into it. The age goes unquestioned, okay? Anything that would contradict the age is just not even considered. Now, I want to play this interview for you. And like I said, listen to what she says about what science says about those structures being able to still exist. Hopefully I can pick this right up where I am.
That dinosaur discovery, the scientific world is still reeling from the discovery of actual Tyrannosaurus rex cells and soft tissue unearthed last week at a Montana excavation site. It's a tremendous find that scientists say could unlock the mysteries of extinction and could one day lead to real-life dinosaur cloning. Well, maybe.
Well, North Carolina State University professor Mary Schweitzer is the leader of the discovery team that found these extraordinary specimens. She joins us now from Raleigh with more. Nice to see you, Professor.
Thank you for having me.
So tell us, how significant a discovery is this?
Well, it has the potential to be very significant, but for right now, until we do further analyses, I think all we can say is it's really cool.
Well, Professor, as I understand it, this was sort of an accidental discovery. You had to split one of the bones in half because it was simply too big to get into a helicopter, and in splitting the bone, you suddenly realized you had this soft tissue on your hands. Is that correct?
Well, it wasn't quite that sudden. They had to split the bone in the field, as was reported, and when it got back to the lab and Carrie Ansell began preparing it, she reserved some of the fragments for chemical analyses, and so it was treated slightly different than most dinosaur bone is in the field.
Is that amazing to find this kind of soft tissue in a fossil this old? And what can the soft tissue really tell us?
Well, it's very amazing. It's utterly shocking, actually, because it flies in the face of everything that we understand about how tissues and cells degrade. It's not something that any one of us could ever predict or hope for. And I think that it's important to remember that we don't know for sure what it still is. It looks like blood vessels, and it looks like bone matrix, and it certainly looks like cells, and it acts like cells. But we haven't done the chemical analysis that let us say what it is for sure.
They have now.
Professor, a word comes to us that the capillary structure or something that you've observed is actually very similar to that of an ostrich, and I'm wondering, does this add fuel to the idea that the dinosaurs and birds were in fact related?
Well, potentially yes. Realize that the blood vessels in your bone look just exactly the same as well. Vessels at the level that we reported in the paper all kind of look the same. It's the molecular constituents that differ from one animal to another, or from animals to humans. So the potential is there to really tell some differences, but for right now that's not something that we can address.
How big a T-Rex are we talking about here, Professor?
This one was quite a small T-Rex relative to, say, Sue that's on display in Chicago. It was significantly smaller, but it was also significantly older. And if I'm remembering what Jack told me correctly, it is the first appearance of Tyrannosaurus rex. So therefore, it's geologically, it's the oldest T-Rex on record.
Would it have wanted to eat us, Mary? Was it a carnivore?
You know, probably. That would be my guess.
Now, is it possible to clone from this kind of tissue? Are we looking at, Ron and I were sort of making fun here of a real-life Jurassic Park, but is that possible?
No. I think all of the obstacles that stand in the way between us and cloning a dinosaur, getting the DNA from the dinosaur is actually probably going to be the easiest, and that's not something we're anywhere close to doing. So once you get the DNA, it will be fragmented and chewed up into little tiny pieces. And so you'd have to figure out how to put all those pieces together. And then you'd have to figure out exactly what order to put them in. Then you'd have to figure out how many chromosomes that dinosaur had and make sure that all of the genes are arranged correctly on the chromosomes. And that's just for starters.
Well, you've anticipated my next question, and let's assume that you can do all of that sort of thing. What might you learn from dinosaur DNA?
Well, you know, I think it's really exciting to learn things like, you guys have probably heard of the idea of molecular clocks, which is a way of taking particular fragments of DNA and comparing them across taxa to get an idea of how quickly DNA might mutate or change. Now we have the opportunity to do that with something that's actually anchored in the fossil record. So that's one potential really exciting thing that might come of this.
And one of the exciting things about this discovery, correct me if I'm wrong, is the fact that this stuff was fossilized as it was. Of 70 million years old, you don't expect to find soft tissue, do you?
Not at all. No. It was utterly shocking.
So you have to sort of rewrite the book as far as fossilization goes, I assume.
Well, that's the exciting part for me. I've always been very intrigued by how things change in going from a living being to part of the rock record. And like I said, a lot of our science doesn't allow for this. All of the chemistry and all of the molecular breakdown experiments that we've done don't allow for this. So if this material turns out to be actual remnants of the dinosaur, then yes, I think we will have to do some certainly rethinking of some of the basics of the model of fossilization.
You know,
Well-
Mary, when I was reading about this story, I was amazed that in some of the capillaries, when you went to pull them, they snapped right back. Are you amazed at the quality of these remains?
Absolutely.
70 million years old, huh?
It's just doesn't seem possible. But yes, you can actually take the vessels, and they do have internal components, and so you can take a probe and kind of squeeze those things out into solution, and the vessels are fine. It's just, I can't explain it, to be honest. I
Very
just can't.
cool.
Well, Professor Mary Schweitzer, congratulations, and thank you very much for stopping by.
Thank you so much.
Okay. That was several years ago, and they have confirmed this actually is original tissues, okay? Did you notice what she said about science? This contradicts everything we know about chemistry and biology and all the lab experiments about how fast tissues dissolve. Have no explanation for it at all. What they're now looking for is an unknown scientific process that can preserve these tissues for tens of millions of years. What they're looking for is a process that counteracts the one we can go measure in the lab. Laboratory science says that is simply not possible. Okay? And it's being replicated all over the place. That's the logical conclusion is simple. The bone isn't that old. Then the problem isn't there. I mean, even thousands of years, it would be astonishing. But millions of years simply isn't possible, chemically, scientifically. So there's a piece of evidence that strongly brings into the question the age of those bones. Okay? So the question becomes, how do they decide how old the bones are? She mentioned that this is firmly anchored in the record, meaning we know how old this is. Okay? There's nothing about that bone itself that would say it's 68 million years old. In fact, we're going to look at something else coming up here that would say it can't be anywhere near that old, aside from or in addition to the soft tissue. But how do they know how old it is? It's presumed to be because of where it is found. So let me go back to this. Okay. Hopefully this works. So, and the age is given by, well, the rocks it's found in are that old. That's how we know how old that fossil is. It's by the age of the geologic structure. So I just went to World Book Encyclopedia, and you look up, how do you date rocks? Here's what it says. Scientists determined when fossils were formed by finding out the age of the rocks in which they lie. Okay, so the age of the rocks tells you how old the fossil is. But go look up a different entry. The rocks are dated by the fossils. Paleontology, the study of fossils, is important in the study of geology. The age of rocks may be determined by the fossils found in them. Notice anything about those 2 entries in World Book Encyclopedia? But what about radioactive decay? Doesn't that provide absolute proof of the ages? That's what everybody thinks. We're going to talk about one form of decay today, carbon-14. Look at this statement. Derek Ager, who published this in New Scientist, is an evolutionist geologist, but he's one of those who's skeptical of some of the standard geological interpretation techniques. But look what he says. No paleontologist worthy of the name would ever date his fossils by the strata in which they are found. Fossils have been and are still the best and most accurate method of dating and correlating the rocks in which they occur. I can think of no cases of radioactive decay being used to date fossils. Okay? Interesting statement. I always thought radioactive decay gave us absolutely calculated ages, and that was it, beyond question. That's anything but the whole story, okay? So, that's just plain old information out there. Look at this one. This is an article in the American Association of Petroleum Geologists talking about mountain building chronologies and the nature of the geologic timescale. My commentary is uranium ages are always corrected by paleontology. Whenever the calculated ages are anomalous, that means they don't match what is expected based upon the fossils there, with the correct age of the fossil, the calculated ages are either corrected or just discarded. I could show you dozens and dozens of instances of this. But here's what Speaker wrote. And what essentially is the actual time scale? On what criteria does it rest? When all is winnowed out and the grain reclaimed from the chaff, it is certain that the grain in the product is mainly the paleontologic record, and highly likely that the physical evidence is the chaff. The physical evidence being the calculated radiometric ages. The paleontologic record is the assumption that we know how evolution worked and about when those creatures lived. What really goes on is if you find any strata with a T-Rex bone in it, you immediately know it's at least 65 million years old. That's just it. It's beyond question. But it was also the case that prior to 1938, any strata containing a coelacanth fossil was also at least 65 million years old, till we found them living. Now, interestingly, they did not go back and say, let's question the age of that strata. No. It's just an interesting anomaly that we don't seem to have any fossilized coelacanths in the last 65 million years. They never actually questioned the ages. Very interesting mindset. Is it circular reasoning? Look at this. Niles Eldredge. These aren't my words, and that's really important to understand. I'm not saying this. I'm not making it up. Niles Eldredge from the American Museum of Natural History, a big-time evolutionist paleontologist, worked with Stephen Jay Gould a lot. And he said, and this poses something of a problem. If we date the rocks by their fossils, how can we turn around and talk about patterns of evolutionary change through time in the fossil record? We assign the time by the fossils that were there. Then we turn around and say, gee, look when these fossils occurred in time. Look at this pattern. He's going, that's a bit of a problem. Something of a problem. The intelligent layman has long suspected circular reasoning in the use of rocks to date fossils and fossils to date rocks. The geologist has never bothered to think of a good reply, feeling that explanations are not worth the trouble as long as the work brings results. This is supposed to be hard-headed pragmatism. And we don't have time today, but one of the most interesting studies that I've ever read was about the dating of one specific skull. And it was a skull that was important for a while in the supposed story of human evolution, so it got lots of attention. Well, there were fossils associated with a volcanic tuff, which we could radiometrically date by potassium argon, one of the techniques. But there were already fossils known to be associated with it, above and below it, which were theoretically tied to human or early pre-human type activity. Okay? So that meant we already know this is only in the range of, no more than 2 to 5 million years old, period. Can't be older than that. So they take and they want to date this volcanic tuff, and they send samples off to the lab. You know what date comes back calculated? 212 to 230 million years. So in the report they go, obviously these dates are anomalous. They're clearly wrong. So they get discarded. Why are they known to be wrong? Because of the fossils already associated with that structure. That's the way it works in the field, and it's easy to show. I mean, it's just, you saw these statements by evolutionists, so I'm not making this up. The charge that the construction of the geologic scale involves circularity has a certain amount of validity. Okay, David Raup, Natural History, Museum of Natural History Bulletin. Okay, yeah, certain amount of validity. It's worth being skeptical of these ages and look at the physical evidence. Don't let the assumption of evolution and therefore the ages be the grain and the physical evidence be the chaff that we throw away. Don't do that. Be skeptical of this and look at the physical evidence. Okay? Let's see. Did I want to do this now? I've got such limited time. I'm going to do this quickly, okay? Change subjects briefly here. Because we brought up on Friday the notion of fire-breathing dragons. How ridiculous is that? I mean, come on. Fire-breathing? We're going to look quickly at some specific creatures that we know about. This little guy is called a bombardier beetle. I'm going to show you a video in a minute, but just notice the spray coming out of its abdomen. This is a boiling hot, noxious liquid, but it's literally boiling. It vaporizes 30% of it inside cavities in its body, okay? And it can control where this spray goes very accurately. It's a defense mechanism. There's a couple other pictures. Look at the smoking gun over here. I mean, just this little beetle, okay? Let's see here. And here's an interesting comment about this, and I just don't have time to show you lots of it. It's fun to watch scientists play with that in the lab. They pin down this little bombardier beetle and then attack it from various angles and get blasted in response. Really interesting. But here's what they say. Given that so many insects play off chemical artillery in defense, there can be no question that diverse spray aiming mechanisms remain to be discovered among insects. PNAS, National Academy of Sciences. So insects have spray aiming mechanisms that can spray boiling hot volatile liquids. Okay? Just keep that in mind here. What do you need to make a flamethrower? Ever think about this? You don't need a whole lot. You got to be able to create and store volatile chemicals, right? Gasoline. Something flammable. And you need to be able to spray it forcefully and accurately, hopefully, so you don't burn yourself up. So you want to control the spray of the chemicals that you've been storing and creating. And you also need to be able to ignite it. You got to be able to control the ignition. If I can do those three things, I can make a flamethrower. Okay? Let's take a look. Let's see, where do I have the video? Nope, back up. I want to show you now another little video. There we go.
In murky tributaries of the Amazon River, one of South America's apex predators uses what could be the strangest hunting tactic of all. This 6-foot-long animal produces what almost no other animal can conjure: a killing shock of electricity. Known as the electric eel, it's a unique creature, more closely related to a catfish than an eel. First, it produces a small electric field, sensing distortions in it to navigate and to find other animals. These fish have no idea that their heartbeats and muscle action are drawing a killer closer. The electric eel probes likely hiding spots. The eel is not going to rest until it's eaten. Sensing prey, the eel flushes it out into the open and delivers its death blow. 500 volts, enough to stun an adult human. Quiet until hunger moves the eel to hunt again. Full, the eel disappears into the murk.
Now this, let me pause this for a second here. Here is, I love the fact everybody wanders around with video cameras now because they're built into your phones, right? Here's some guy off in the woods probably hunting, and he comes across something rather interesting. And then you'll hear he actually provokes something by whistling. Whoever it is that's filming this, I don't understand the language. If anybody understands the language you hear, let me know what it is. But what you wind up with is an electric eel and a alligator, or crocodile, alligator looks like, at this, next to each other on the bank of this little river off in the woods somewhere. Watch what happens to this alligator.
Tá tomando choque da CND. O jacaré tá morrendo.
There's one dead alligator. So, there we go. So, what they didn't describe in either of those videos, the electric eels not only can produce that kind of electric power, okay, they also can very well control it. I mean, their body not only produces electricity, they've got the full-on control mechanism to discharge it when they want, for how long they want, and what intensity they want. Okay? A complete control mechanism for it as well. Now here is some video of the bombardier beetle.
My name is Jason Schaller, and I'm a graduate student here at the University of Arizona in the Department of Entomology. We focus primarily on beetles and other arthropods, particularly those found in the Madre and Sky Islands here of southern Arizona. I've been doing a lot of research with bombardier beetles, but more of a behavioral approach. I've actually been collecting aggregations from around the state, analyzing them for species content, because there are multiple species of bombardier beetle in Arizona, 14 to be exact. They've got one of the most unique defense mechanisms in the animal kingdom. Now, they belong to the ground beetle family, Carabidae. On each side of the beetle, in the rear section, you have two chambers that produce chemicals. The first chamber produces one chemical that goes into the second chamber. And when that first chemical goes into the second chamber and meets the other chemical, they react. And when they react, they produce a lot of heat. And this happens at about 100 degrees Celsius, which is the boiling point of water. Now, in just an instant, that hot chemical gassy mixture just bursts out of the back of the beetle at high speeds and makes a little psst sound and a little explosion, and it's scorching hot when it comes out. really cool little structures. They're almost like Gatling guns on an airplane. They can just move in any direction. There's 2 of them. Each one is connected to the 2 chambers on each side, and they're like little nozzles that move. And they can go straight back. They can come outward and aim forward. They can aim at all the sides, and they can just, wherever the predator is coming from, they can aim it and just blast it right in the face.
I hope nobody's too bothered by snakes. This doesn't last too long. Super slow-mo is truly amazing, and we can see things happen. It's called a spitting cobra. A lot of venom. Well, it's it for your vision unless you get something done really fast. Yep. They're quite dangerous. Now, before I show you this, think about what we just looked at. The capability in these creatures, okay? The spitting cobra, by the way, they can accurately spit more than their body length. I've read at least 8 feet. I saw one researcher who put on like a welding mask you could see through and deliberately antagonized one of these things. And do you notice how the head was moving in the slow-mo when it spit? It gets this whole great little spray pattern. And they aim at your eyes. And these snakes react to photographs. They're visually looking for the eyes of the predator that they're not just heat sensing like vipers do, for example. They look for eyes, they spit venom at it, and it's a very effective defense mechanism. Okay? But what I want you to focus on is the ability to very accurately, under full control, eject a liquid at a target. Okay? The bombardier beetle also has a delivery mechanism and produces and stores volatile chemicals. If those chemicals mix in an uncontrolled way, that's it for the bombardier beetle. I mean, it's dead. Okay? The researcher mentioned the 2 vessels, and the liquid flows from one chemical from one into another. You get a catalytic reaction, a very rapid reaction. He didn't mention there's a little backflow valve between them that keeps the reaction occurring in the second vessel from backflashing into the first one and blowing the whole thing up. I mean, there's a lot of details to the control mechanism, and you saw how it works. It's fully functional, okay? Now combine those. Think about a creature that's big, like, let's say a dinosaur. By the way, several dinosaur skulls have, we don't know if this relates or not, but they have an interesting shape to some of them. They have large hollow cavities in the skulls. Nobody knows for sure what their purpose was. Some have thought, well, that would make them able to produce sound or, various ideas. Well, some creationists are saying perhaps they had organs in there to store liquids. We don't know what they were. We just know they had large vacuous space in their skulls. But get a large creature with the ability to produce a noxious liquid and then spray it in a controlled way like that snake does, and then take the electrical generating capability of an electric eel, I got no problem making a flamethrower. You get that. I mean, I've got an igniter for my grill that uses like 1.5 volt batteries, okay? They can produce 500 to 600 volts. I mean, it's not a problem at all to put these pieces together into one biological creature and have this. It's just simply, it's possible. guys are having fun, aren't they? Notice the size required for him to do this. We're not talking about needing a tank. You don't need something, the size of this room. You need something a guy can carry around on his back. The volume, weight, delivery, all the pieces are there to make it feasible. Does that prove anything? No. Except for one thing. It does prove one thing. It proves that it is not impossible that there were fire-breathing dragons. It does prove that. It's possible. It's plausible even, but it doesn't prove it existed. But it does remove the statements that, that's impossible. Fire-breathing? Think about it. It is possible. Creatures have amazing capabilities. Some butterflies navigate thousands of miles by sensing the Earth's magnetic field. The things that some living creatures can do are just astonishing. It's a very interesting study. So, and everybody made it through the snake okay. I made the mistake when I showed this in a class of pausing right on one of those pictures with the snake's mouth open, and I paused it, and I found out later from my wife, one of the ladies in class nearly got sick because she has a phobia about snakes. It didn't even occur to me. So, oh well. Now, let me pause for just a second right here and entertain any questions related to this. I'm going to change subjects here to look at carbon-14 dating. But any questions on what we've been talking about?